Yes, high voltage can shorten the lifespan of a 277-volt ballast. Ballast failures can occur more frequently if the input voltage exceeds the rated voltage by more than 5%. In this case, a high voltage of 284 volts is significantly higher than the rated voltage of 277 volts. Several factors might be contributing to this high voltage issue. Firstly, incorrect wiring could be a culprit. The circuit may not be properly wired, causing excessive voltage drop. Secondly, an overloaded circuit can lead to voltage fluctuations. Thirdly, a recent power surge may have damaged the electrical equipment and caused the voltage to remain elevated. If a voltage problem is confirmed, there are several options to explore in order to drop the voltage. 1. You could install a step-down transformer to reduce the voltage from 284 volts to 277 volts. 2. You could add capacitors in parallel with the ballast to absorb excess voltage. 3. You could install a voltage regulator that automatically adjusts the voltage to the desired level. It is also important to consider other possible causes of ballast failures. 1. It is possible that the ballasts were defective from the manufacturer. 2. Inadequate ventilation or high ambient temperatures can cause ballast overheating and failure. 3. Faulty fluorescent lamps or end-of-life lamps can also lead to ballast failures. To properly assess the situation and implement the correct solution, consider these recommendations. Use a voltmeter to measure the voltage at the ballast location. Inspect the electrical system for any wiring errors or overloads. If you are not comfortable with electrical troubleshooting, contact a qualified electrician for further assistance. Replace all ballasts that have failed, regardless of the cause. Regularly check the voltage at the ballast location to ensure it remains within the acceptable range. When dealing with ballast failures, it's important to address the root cause to prevent future issues. Factors like high voltage, defective ballasts, heat buildup, and fluorescent lamp issues should be investigated to determine the appropriate course of action. High voltage, exceeding the rated voltage of the ballast, can stress the internal components and lead to premature failure. The excess voltage can cause increased current flow, generating more heat and accelerating the degradation of the ballast components. This can manifest as flickering lights, reduced light output, or complete ballast failure. Defective ballasts, whether due to manufacturing flaws or component aging, are another potential cause of failures. Manufacturing defects can include faulty windings, poor insulation, or incorrect component values. Component aging can occur over time due to heat, vibration, and electrical stress, leading to reduced performance and eventual failure. Heat buildup, caused by inadequate ventilation or high ambient temperatures, can also contribute to ballast failures. Ballasts generate heat during operation, and if this heat is not dissipated effectively, it can lead to overheating and reduced lifespan. High ambient temperatures can exacerbate this problem, further stressing the ballast components. Fluorescent lamp issues, such as faulty lamps or end-of-life lamps, can also cause ballast failures. Faulty lamps can draw excessive current or create voltage imbalances, stressing the ballast and potentially causing it to fail. End-of-life lamps can also exhibit similar behavior, as their internal resistance increases and they draw more current. Now let's dive deeper into voltage reduction methods. Transformers are a common solution for reducing voltage. Step-down transformers are designed to reduce the voltage from a higher level to a lower level, such as from 284 volts to 277 volts. These transformers use electromagnetic induction to transfer electrical energy from one circuit to another with a lower voltage output. Capacitors can also be used to absorb excess voltage. When connected in parallel with the ballast, capacitors can store electrical energy and release it back into the circuit when the voltage drops. This helps to smooth out voltage fluctuations and reduce the overall voltage level. Voltage regulators are devices that automatically adjust the voltage to the desired level. They use electronic components to monitor the voltage and adjust the output voltage accordingly. Voltage regulators can be particularly useful in situations where the voltage fluctuates frequently. When troubleshooting ballast failures, it's important to follow a systematic approach to identify the root cause. Start by visually inspecting the ballast and the surrounding components for any signs of damage or overheating. Look for discoloration, swelling, or leakage of components. Next, use a voltmeter to measure the voltage at the ballast location. Ensure that the voltage is within the acceptable range for the ballast. If the voltage is outside of the acceptable range, investigate the wiring and circuit for any errors or overloads. Check for loose connections, damaged wires, or undersized conductors. If you suspect that the ballasts are defective, consider replacing them with known good ballasts. Monitor the new ballasts to see if the problem is resolved. If the problem persists, then the issue is likely not with the ballasts themselves. If you are not comfortable with electrical troubleshooting, it's best to consult a qualified electrician. Electricians have the training and experience to diagnose and repair electrical problems safely and effectively. Regular voltage monitoring is essential for preventing future ballast failures. By regularly checking the voltage at the ballast location, you can identify potential problems early on and take corrective action before they lead to ballast failures. In addition to addressing the immediate issue of ballast failures, it's also important to consider the overall electrical system. Ensure that the wiring is properly sized, the circuit is not overloaded, and the grounding is adequate. These factors can all contribute to voltage fluctuations and ballast failures. Another consideration is the type of ballast being used. Electronic ballasts are generally more efficient and reliable than magnetic ballasts. Electronic ballasts also offer better voltage regulation and protection against voltage surges. Therefore, consider upgrading to electronic ballasts if you are still using magnetic ballasts. When replacing ballasts, it's important to choose ballasts that are compatible with the lamps being used. Using incompatible ballasts and lamps can lead to reduced light output, flickering, and ballast failures. Always consult the lamp manufacturer's specifications to ensure compatibility. Furthermore, ensure adequate ventilation around the ballasts to prevent heat buildup. Ballasts should be mounted in a location where they can dissipate heat effectively. Avoid mounting ballasts in enclosed spaces or near heat sources. Consider using ballasts with built-in thermal protection. These ballasts will automatically shut down if they overheat, preventing damage to the ballast and the surrounding components. When replacing fluorescent lamps, it's important to choose high-quality lamps that are designed for long life and efficient operation. Low-quality lamps can have shorter lifespans and can cause ballast failures. Consider using energy-efficient lamps, such as Tate or T5 lamps. These lamps consume less energy and produce less heat than older T12 lamps. In summary, high voltage can indeed shorten the lifespan of ballasts, and addressing this issue requires a comprehensive approach. By identifying the root cause, implementing appropriate voltage reduction methods, and addressing other potential factors, you can prevent future ballast failures and ensure the reliable operation of lighting systems. Firstly, verify the voltage. Use a voltmeter to measure the voltage at the ballast location to confirm if it is exceeding the rated voltage. Secondly, check the wiring and circuit. Inspect the electrical system for any wiring errors, loose connections, or overloads that may be causing voltage fluctuations. Thirdly, consider using a step-down transformer to reduce the voltage from the incoming supply to the required level for the ballasts. Fourthly, add capacitors in parallel with the ballasts to absorb excess voltage and stabilize the voltage. Fifthly, install a voltage regulator to automatically adjust the voltage and maintain it at the desired level. Sixthly, ensure proper ventilation around the ballast to prevent heat buildup, which can contribute to ballast failures. Seventhly, consider replacing the existing ballasts with electronic ballasts, which are more efficient and offer better voltage regulation. Eighthly, replace any defective or end-of-life fluorescent lamps, as they can cause ballast failures. Ninthly, regularly monitor the voltage at the ballast location to ensure it remains within the acceptable range. Tenthly, if you are not comfortable with electrical troubleshooting, contact a qualified electrician for further assistance. Remember to prioritize safety when working with electricity. Always disconnect the power before working on any electrical components. If you are unsure about any aspect of the work, consult a qualified electrician. By following these recommendations, you can effectively address the issue of high voltage and prevent ballast failures, ensuring the reliable and efficient operation of lighting systems.